Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson Is Matter Around Us Pure? Now if you all remember in part 1, like as that was the introductory part to you, right, on lesson Matter Around Us, whether it is pure or not, right? We discussed on so many things in the last part where we discussed on like what exactly an element is, what is matter, is the matter around pure, right? And there were so many things that we were discussing, right? So I just want each one of you to please revise whatever we have studied in the last class. I'll be helping you with some of the points as well, like if you have missed it out, I'll be helping you with that as well. But before that, I want each one of you to revise whatever you have written in your book on matter around us pure. Is matter around us pure? Okay. So I hope everyone has revised whatever you had in your book, like whatever points you have written in your book. Now we have like so many things to discuss in the lesson. I have shown you all the topics that we are going to discuss. I have even like shown you the explanation, like exercise questions, like which are the different types of questions that you can, like you have to answer while we complete the lesson, right? So now I hope every one of you have an idea on what is this lesson all about, right? Because when I started with it in the first part, you were knowing nothing, right? You had some of the basic ideas on matter and element, but now when we are on to part 2, you have an basic idea on what are the topics that we are going to discuss about and what is this like lesson relating to, what exactly you're going to study in the lesson, right? So now I'm going to start with the lesson by discussing about the classification of matter. Now if you remember, in the last class itself, like I taught you what is matter, right? If I tell you to define matter, the most simple explanation that you can give, or the statement that you can give, is matter is something that occupies mass, that occupies space and have mass. Okay, so everything around you, every object around you is occupying some amount of space, right? And it is having some mass, so we know them as matter. So now here the first topic under this lesson is matter around us pure. The first topic that we have over here is classification of matter. So let's study more about it. See, how do we judge whether milk, ghee, butter, salt, spices, mineral water, or juice that we buy from the market are pure? How do you judge that whether it is pure or impure? If you know, like, these are some of the consumable items which have been given over here, like the salt, which is free, like extra free flow iodized salt in it. Then the name of the ghee itself is pure ghee, pure milk. They specify that on the product, right? That it's pure. So have you ever noticed the word pure written on the packs of these consumables? Now if I tell you to go and like have a quick glance in your kitchen on all the products that has been kept, and go and find out how many products that you can find out which is having this word pure on it. Come on, I want every one of you to do this activity. Go in your kitchen and try to find out as many products as you can in 2 minutes. Okay, not more than that. Let's see how many products you can find. Okay, so I hope every one of you are back looking at the item, and you might have at least got one or two products, right? So for a common person, pure means having no adulteration, right? Now we all can consider ourselves as a pure person. No, not pure person, a common person, right? Because we all are not scientists. So for us, pure, the word meaning of the pure is that it is having no adulteration. There is nothing added in it, which is like not good for us. There is no adulteration in that, right? But when it comes to scientists, all these things are actually mixtures of different substances and hence not pure. Now if I talk about pure milk, now for us the word pure means that it is free from adulteration, it is pure. But according to scientists, they are actually mixtures of different substances. For example, now we know that we cannot get milk like this way. Milk is a mixture, right? Milk is actually a mixture of water, fat, and proteins, and along with that there are so many things which are been present in the milk, so it's not considered as pure. So according to scientists, all these things are actually mixtures of different substances, and the example has already been said that it's milk, and milk is a mixture of water, fat, protein, right? So when a scientist say that something is pure, it means that all the constituent particle of that substances are same in their chemical nature. It means whatever particles with which the milk has been made up of, they are all same in their chemical nature, and that is why they are stating it as pure. So a pure substance, it consists of single type of particle. What does it consist of? It consists of single type of particles. Okay, it doesn't mean that it is free from adulteration. It means that if I say about pure ghee, pure milk, it means that they are made up of single type of particles. All the particles which are present in milk, they are all single type of particles. Okay, and in other words, a substance is a pure single form of matter. What it is? Substance is a pure single form of matter, and as we look around, we can see that most of the matter around us exist as mixtures of two or more pure components. For example, we have seawater, we have minerals, soil, these are all mixtures. Okay, so everything around us is made up of, like, we have is like all mixtures which are made up of two or more components mixed together. Got it? Like, what is the exact meaning of the word pure over here? It does not mean that it is free from adulteration. It's just a kind of like thing that we have in our mind. For a common person, if the brand is stating pure, it means it is free from adulteration, but it is not as such. It means it is made up of single type of particles in it. Okay? So I just want you all to write all the important points that you find over here, and even like go through the slide once, because that is very important. I hope everyone is going through the slide and even taking on the, like, you're writing down the important point. After this, like now I hope you have written about this pure thing. Okay. See, what is a mixture now? Now you know what is pure substance and everything. See, mixtures are constituted by more than one kind of pure form of matter. Now, pure means a single particle. So, when more than one particle get mixed together, okay, that leads to the formation of mixture. So mixtures are constituted by more than one kind of pure form of matter, and we know that dissolved sodium chloride, now sodium chloride is NaCl, right? So dissolved sodium chloride can be separated from water by the physical process of evaporation. Now I hope every one of you have like studied it. Yeah. So how can we separate the sodium and chloride, or we can separate salt from water? So we can do that through the process of evaporation, and we have studied this in 8th class as well, right? So I hope you all remember it. So however, sodium chloride is itself a pure substance, and it cannot be separated by physical process into its chemical constituent, because sodium chloride, when you are mixing it with water, it means you're mixing salt with water. Then if you have to like separate the salt from water, we can have this evaporation process which can be done, right? But when you consider sodium chloride, it is itself a pure substance. It is made up of only one particle, and that is the reason we cannot separate it by any of the physical process into its chemical constituent. Okay. So similarly, when it comes to sugar, now sugar also contains only one kind of pure matter, and its composition is going to be same throughout, right? So salt and sugar, they both are pure. Why? Because they are made up of only a single kind of particles. They are only made from single kind of particle. Then we have soft drink and soil. Now soft drink and soil, they are not single pure substances. Okay, so whatever the source of pure substance may be, it always have the same characteristic properties. So therefore we can say that a mixture is going to have more than one pure substance in it. So here we have example as like sodium, chlorine, nitrogen, water. Now mixture is something which we already know, like when bhel, we all eat bhel, right? Bhel is a very good example of a mixture because it has onions in it, then it has like so many things added in it. So that is a mixture, right? It means anything that is made up of more than one particle, one kind of particle, that is mixture. Okay, and if it is only one single particle, then it's going to be a pure substance. Getting my point, everyone? I just want you to write about mixture as well, and even after writing about mixtures, make sure you're going through the slides as well. I hope everyone is writing about like mixture, and you are even writing about like how can we separate salt from water, and that can be done through the process of evaporation. I hope everyone is done with this, like after studying on what are pure substances. Now the second thing that we studied was what is a mixture, and I hope you're clear with it. Like how will you write a note on mixture? If I tell you, you can write all the points which have been explained over here as well. You can add them as well, okay? After this, we have to study on types of mixture. Now you know what exactly a mixture is. So now we will be studying on like what are the different types of mixtures that exist. So see, depending upon the nature of the components that form a mixture, we can have different types of mixture. Now it all depends upon the nature of the components that are going to come together and form a mixture. So depending on them, we can have different types of mixture. And for studying the types of mixture, we have an activity 2.1. Activity 2.1 to discuss. So see, now what are we going to do is, let us divide the class into group A, group B, C and D. So there are total 4 groups in the class now. Group A is going to come forward. Now you have to imagine this thing happening, okay, that there are 4 different groups in front of you. You can consider yourself as of any one group, okay. So group A is going to like take a beaker containing 50 ml of water and 1 spatula full of copper sulfate powder. What is this group 1 going to take? Group 1 is going to take 50 ml of water and 1 spatula full of copper sulfate powder. Okay. Group B is going to take 50 ml of water and 2 spatula full of copper sulfate powder in a beaker. So group 1 has taken, both of them are taking. See, every group is going to take copper sulfate. That is going to be common. So group A is taking copper sulfate, but it is only 1 spatula along with 50 ml of water. Group B is taking 50 ml of water and 2 spatula. You can say 2 spatula full of copper sulfate powder. Okay. Now group C and group D can take different amount of copper sulfate and potassium permanganate or common salt and then mix the given component to form a mixture. So group A and group B, they have taken a specified amount, whereas now group C and group D, they are going to take different amounts of copper sulfate and potassium permanganate, and they need to mix the components so that they can form a mixture. Okay, then report the observation on the uniformity in color and texture. Now we have 4 different groups. For all the 4 groups, so everyone is going to study what will be the observation and result of all the 4 groups. So we have to report the observation on uniformity in color and texture. Okay, and when you observe it, you will see group A and B, they have obtained a mixture which has a uniform composition throughout. Okay, what this group A and B will have? They will have a mixture which is going to have uniform composition throughout. Okay, and such a mixture who are having this uniform composition throughout, we know such mixture as homogeneous mixture, or we can even call it as solutions. What we can call it as? Solutions. Okay, and some other examples of mixtures will be salt. Now we know salt dissolved in water, sugar dissolved in water. These are all example of homogeneous mixture because they are going to have uniform composition throughout it, right? Then we need to compare the color of the solution of the 2 groups. Though both the groups have obtained copper sulfate solution, but the intensity of the color, like one of the group will have like very dark color, one of the group can have very light color, or the intensity of the color, that is how it is going to be different, right? So this shows that a homogeneous mixture can have a variable composition. What does it have? A homogeneous mixture can have a variable composition. Got it? So I just want you all to please go through this activity once. So here we studied about homogeneous mixture. So the mixture which has a uniform composition throughout, such mixtures we call it as homogeneous mixture, or we can even call it as solution. Got it? I hope everyone is going through this slide. After this, now we have one more activity to discuss, but before that, please go through the homogeneous mixture which has been explained over here. Okay, now let's see this activity 2.2. So see, let us again divide the class in four groups, and we are going to have four groups as A, B, C, D. You can choose your own group and distribute the following sample to each group. Now each group is going to have different samples, okay? Group A will have few crystals of copper sulfate. Group B will have one spatula full of copper sulfate. Group C will have chalk powder or wheat flour, and group D will have few drops of milk or ink. Got it? Group A is having few crystals of copper sulfate. Group B will have one spatula full of copper sulfate. Group C will have chalk powder or wheat flour, and group D will have few drops of milk or ink. Okay. Now what you have to do is each group should add the given sample in water and stir properly using glass rod. So in whichever group you are and whatever sample you have, you just have to mix that in water and then stir it properly using a glass rod. Okay, and after stirring it properly, you have to check, are the particles in the mixture visible? Like if you are in group 1 and if you have added crystals of copper sulfate, you need to check after mixing in water, is the crystals of copper sulfate visible to you? Is the chalk powder which you have added visible to you? Is the drop of milk visible to you? That is how you need to check that. Okay, and after that, direct the beam of light from a torch through the beaker containing mixture and observe from the front. Now we have to take a beam of light from a torch. We have to like take that beam through the beaker containing the mixture and observe the front. Okay, and we need to check, was the path of the beam of light visible? What do you think when you pass a beam of light through the sample that you have got? Will you think that the beam of light be visible to you? And after doing this, we need to leave the mixture undisturbed for few minutes and set up the filtration apparatus in the meantime. Okay, can you see figure 2.2, the filtration mechanism? For that you need to have a filter paper and you need to make a cone of filter paper. So you have to follow the steps as been shown in A, B, and that is how you will get the C. Okay, after making it, you need to take the test tube. You have to add the filtrate inside the test tube and take your like filter paper on the top, put your sample in it, and taking the glass rod, just stir it. So the liquid decanted in the funnel is treated with a filter paper. Okay, so you have whatever like sample you have taken, crystals of copper sulfate, spatula of copper sulfate, anything that you have taken, you need to pass it through the filter paper and check whatever has been left behind. Okay, then after doing this filtration, filter the mixture, and you have to check if you are getting any residue on the filter paper or not. Okay, residue means like if the copper sulfate is not getting dissolved, there will be some residues which will be present over there, right? So you need to check, is there any residue on the filter paper, and discuss the result and form an opinion over there. So when you do this filtration process, you pass a beam of light through it. Okay, you will find out that group A and B have got a solution, group C has got a suspension, and group D has got a colloidal solution. Okay, now group A and group B, they have got a solution. Why? Because they have got copper sulfate. So when you mix it and you do the filtration process further, you can find out whether it's a solution, it's a suspension, or it's a colloidal solution. Now milk is a colloidal, very best example of colloidal solution. Suspension के लिए we have the good example as wheat flour or chalk powder, and solution we have is copper sulfate, crystals of copper sulfate. Got it? We'll study what exactly now solution, suspension, and colloidal solutions are, but before that I want you all to like just draw this figure 2.2 for filtration in your book, and even write any point if you want to write it. I hope everyone is going through it and you're drawing the figure as well. I hope everyone has drawn the figure till now. And even now you can write that group A, which had you can say crystals of copper sulfate, they have got a solution. Group C, which had chalk powder or wheat flour, has got a suspension. And group D, which has few drops of milk or ink, they have got a colloidal solution. After this, now we have the question as like what is a solution. As I said, we will be discussing in detail like what exactly solution, suspension and colloidal solutions are. So let us first study like what exactly a solution is. Okay, see, a solution is a homogeneous mixture of two or more substances. So when we are mixing two different substances together, we call that substance as a solution. Okay, so you came across various types of solutions in your daily life. You come across, right? We have laminate, soda water, they are all examples of solutions. So usually when we think of a solution as a liquid, this liquid is either going to have a solid, liquid or a gas dissolved in it, right? Whenever you think of any of the solution around you, you will find out that that solution is either going to have a liquid mixed in it, a solid mixed in it, or a gas dissolved in it, right? But we can also have solid solutions, like it can be any alloy, or we can even have gaseous solution, which can be an air. Okay, so in a solution, there is homogeneity at the particle level. For example, laminate, they taste the same throughout, right? And that is why we call that they have this homogeneity at their particle level. They are homogeneous in their level, right? Because they don't taste different at different level, they're going to taste the same throughout. So this shows that the particles of salt or sugar, they are evenly distributed in the solution. Otherwise what will happen, when you taste it in the start, you will feel like there's more lemon, and then slowly and steadily you will feel like there's more salt in it, like that way, right? So this shows that particles of sugar or salt, they are evenly distributed in the solution. Okay, and a solution has a solvent and a solute as its component. So solvent means the liquid component and solute means the solid component. Okay, so if you can see below the diagram, we have the definition of solute and solvent which has been given. Wait, I'll show you where exactly it is. Can you see this part? This one I'm telling. The solute is the substance that gets dissolved. Okay, and the solvent is the substance that does the dissolving. So solute is the substance which is going to get dissolved, like salt and water. In salt and water, we know the salt is going to get dissolved, so salt becomes the solute, and solvent is the one in which the solute dissolves. So water is the one in which the salt is getting dissolved, right? So salt becomes the solute and water becomes the solvent. Okay, so the component of the solution that dissolves the other component in it, usually the component is present in larger amount, that component we call it as solvent because it is dissolving the other component in it. Okay, and the component of solution that is dissolved in the solvent, usually which is present in lesser you can say quantity, we call them as solute. So I just want you to write about this, like they have that solutions have homogeneity at particle level. You need to write example of it. You need to write that they are evenly distributed. Then you need to write that a solution has a solvent and a solute in it, and what exactly a solute is and a solvent is, along with these two diagrams. Okay, but you have to be very quick with whatever you are taking a note of. Once you complete writing, I'll teach you about diluted solution, concentrated solution and saturated solution, all the three different types of solutions in detail. Okay, I hope every one of you are writing it. I hope everyone is written, and even you have written about what exactly a solute and a solvent is, right? So after this, like, we will be discussing on three different types of solutions that we have. That is diluted solution, concentrated solution, and saturated solution. Okay. So see, diluted solution means what? We have added water with it. Like the solute that we have, like the more concentration is of water. Okay. So they are going to have very less solute in it and can dissolve a lot more solute in it. Okay. Then when it comes to concentrated solution are going to have a lot of solute in it. See, diluted has only little solute in it. Concentrated solution will have a lot of solute in it, and saturated solution will have maximum amount of solute in it. Okay. Then when it comes to how much amount of solute that they can dissolve, so diluted solution can dissolve a lot more solute, concentrated solution can dissolve a little more solute, and saturated solution cannot dissolve any more solute because they are already having maximum amount of solute, so further they cannot dissolve it. Okay, so I just want you to like write this in your book about diluted, concentrated, and saturated solution because this is also very important. Okay. I hope everyone has started writing about all the three types of solutions that we have. You need to even draw the beaker showing, like you can just shade it differently. For diluted, concentrated, and saturated solutions. Okay, so I hope you all are done writing about diluted solution, concentrated solution, and saturated solution. You have even understood about what are solutes, what are solvents, and what exactly a solution is, right? So now the next thing that we have is some of the examples of it. See, a solution of sugar in water is a solid in liquid. Now we know sugar is solid and water is liquid. So a solution of sugar in water is a solid in liquid solution, right? So in this solution, sugar is going to get dissolved in water. So sugar is a solute and water is the solvent which is going to dissolve the solute, right? So water becomes the solvent. I hope you all are getting it how to like identify a solute and a solvent. Then we have a solution of iodine in alcohol, which is known as tincture of iodine. So in this tincture of iodine, because we know that iodine is mixed with alcohol, now iodine is going to be the solute because that is what is getting mixed in the solvent, right? So iodine is going to act as a solute and the alcohol in which the iodine is dissolved, it acts as a solvent. Getting my point, everyone? Like this is how you need to identify what is a solute and what is a solvent. Okay. Then the third example that we have is of aerated soft drinks, like aerated drinks like soda water, soft drinks and all. They are gas in liquid solution because when you like open this bottles of the soft drinks bottle or aerated drinks, you can see that gas coming out of it, right? So they are gas and liquid solution, and this aerated drinks contain carbon dioxide gas as a solute and water as a solvent. Okay, so air is a mixture of gas and gas. We all know that air is made up of so many different gases all together. So we can say that air is a mixture of gas and gas, and air is a homogeneous mixture of number of gases. So there are different gases which are present in air, so it becomes a homogeneous mixture of different gases, where the two important constituent of this air are oxygen and nitrogen. So oxygen is present in 21% of concentration and nitrogen as 78 percentage. Okay, so these are the two important constituents of air that we have, where nitrogen is percent, like 78% of nitrogen and 21 percentage of oxygen. And there are other gases as well which are present, but that is present in very small quantity. So 78 plus 21 is 99. So the other gases which are present is only 1% of the other gases are present in air. Okay, so you should be like knowing about the examples of the solution. So I just want each one of you to please go through it once. I hope everyone is writing the example in your book. Okay. Now, after this, we have the properties of solution to discuss. So, see, a solution is a homogeneous mixture, and the particles of solution are smaller than 1 nanometer. Okay, they are smaller than 1 nanometer in diameter, so they cannot be seen by the naked eyes. Okay, we cannot see this with naked eye. Because of very small particle size, they do not scatter a beam of light passing through the solution, and that is why the path of light is not visible in a solution. Okay, so the solute particles cannot be separated from the mixture by the process of filtration. We cannot separate the solute particle from a mixture from by the process of filtration, because the solute particle, they get dissolved in it, they don't get settled down when left undisturbed, and that is why we say that solution is stable. Okay, and here we have like different homogeneous mixtures examples which have been given, so I just want each one of you to please go through it once. I want you all to please write the properties of it. Now, concentration of solution, I will start in the next part. But for now, I want you all to write the properties of solution in your book along with the examples which are been given over here. Okay? I hope you all are writing all the points like about the properties of solution in your book, as this is all important point, because if you have been asked to write about solution, you will have to add about the examples of solution, about the properties of solution, everything. So like for now I'll be stopping over here. I'm giving you some I hope whatever we studied about the different types of solutions we discussed about the activities, you have understood everything about it. Okay, now in the next class I'm going to start with like what exactly is the concentration of a solution. We'll discuss in detail about concentration of solution. Then after that we'll discuss on this activity 2.3 in detail. Okay, after this activity, like we have some of the you can say concentrations of the solutions which have been given, and that these are the different ways how can we express the concentration of solution, because that is very important. So we'll discuss over here where we have three different ways: mass by mass percentage of a solution, mass by volume percentage of a solution, and lastly we have is volume by volume percentage of solution. So these are the three different ways like methods which we are going to study in detail. Okay, then we are going to apply that through we are going to apply it and study it through an example again. Okay, then we'll discuss on what exactly a suspension is, because we will be completing with solution over here. Okay, and after studying about solution in detail, we will be discussing on what exactly suspensions are, what are the different properties of suspensions. Then we'll discuss about Tyndall effect in detail, what exactly Tyndall effect is. Then we will start discussing about colloid. So we will be like discussing about the different properties of colloids, few of the examples of colloids, and then we'll discuss on the methods to separate the components of a mixture, because we know mixture is made up of two or more different substances together, mixed together, right? So we will be studying on how can we separate the components of mixture in detail. After that we will discuss on like how can we obtain colored components from blue or black ink, and we will be studying that through an activity 2.4. Okay, then we'll discuss on like how can we separate cream from milk. Now we usually do that at home, right? How do we separate cream from milk? We will be discussing on that. Then we'll discuss on activity 2.5 in detail. After this activity 2.5, we will be discussing on that how can we separate a mixture of two immiscible liquid. Okay, so we will discuss about that. We will discuss the application, like what if we are separating a mixture of two immiscible liquids, what will be the application, like where can we apply this separation technique. Okay, then we'll discuss on how can we separate a mixture of salt and camphor. We will like discuss that in detail. Then we'll discuss about that is the dye in black ink a single color or it's a mixture of different color. So we will again discuss this thing through an activity, that is activity 2.7. Okay, after that we will discuss on like how can we separate a mixture of two miscible liquids, and separating two miscible liquids again we are going to discuss that through an activity 2.8. Okay, we'll discuss that in detail about distillation process over here, because like fractional distillation, these are the different methods that we are going to study under this, like how can we separate the mixture of two miscible liquids. And then we'll discuss on how can we obtain different gases from air, because we know that air is a mixture of gas. So the question occurs is like how can we separate or how can we obtain those different gases in detail. Then we'll discuss on like how can we obtain pure copper sulfate from an impure sample. Now if you remember, while discussing about solution in detail, this is the exact same figure that we have studied today, right? So we will relate it and we will study this as well. After this we are going to discuss on like the activity, the figure is for this activity explanation, so we'll do that as well. Then we will even study the application of it, like whatever process that we are studying over here, you need to even know like where are we going to apply it, what is going to be the application for it. Okay, then after discussing so much, we will discuss on what are physical change and what are chemical change as well in detail. Okay, with different examples. Then we will be discussing on like what are the types of pure substance. Okay, so on the basis of chemical composition, we can classify substances as elements or compounds, right? So we'll discuss about the types of pure substance, where we are going to discuss about elements in detail. Okay, after discussing elements, we will be discussing on the properties of metal. Okay, so you should be knowing about like what are the different properties of metal. So these are the physical properties of metal that we will discuss about. We'll discuss about compounds. What are compounds exactly? So compounds are like composed of two or more elements, and they will be chemically combined together in a fixed proportion. Okay, we have already discussed about the differentiation between mixtures and compounds, right? So we'll discuss about that. Then we will discuss on activity 2.10 in detail. Then after that we will discuss on like this is the differentiating table that we have between mixtures and compounds. We will discuss it even. Okay, then after that like we have the differentiating table between pure substances and mixtures, because matters can be further classified as pure substances and mixture, right? And pure substances are even further classified as elements and compounds, and mixtures are further classified as homogeneous mixture and heterogeneous mixture. So we will discuss about that, and then we have this summary discussion on whole lesson, that is matter around us pure. Okay, so we'll do this summary discussion, and then we have some of the exercise questions to discuss as well. So I'm just showing you the questions one by one. I want each one of you to please have a quick glance through all the questions which are there on the screen. I hope everyone is going through the question. So like there are so many sub questions which have been given under the questions part, right? So we'll be discussing about all of them in detail one by one. So just keep a note of these questions every time when we go through it. Once we end up with the lesson, we are going to discuss all the 11 questions which have been given. Okay. So I hope whatever we discussed in this part you're very much clear with it. Now whatever part has been left, I will be continuing that in the next class. Thank you everyone.